Now let's just see the question number 3, which says in an AP, A3 is 15, S10 is 125, find D and A10. So first of all, let us suppose if I'll write a note over here. The note says that the sum of the terms S can also be represented as Sn, which is equal to n by 2, 2a plus n minus 1 into D. So it means if we are writing the sum of the terms as S, we can also represent it as Sn, and Sn or S is one of the same thing, which is n by 2, 2a plus n minus 1 into D. So hence, using this concept, let's just proceed for the answer for this one. As we can see, we have the third term given to us as nothing but 15. So we can write it as a plus 3 minus 1 into D, which is equal to 15, because we know that an is nothing but a plus n minus 1 into D. Further, we can sort it out as a plus 2D, which is equal to 15. So let us suppose I am calling this as equation number 1. Now let's proceed further for the S10. We have given S10 as nothing but 125, and we know that we can represent S10 as nothing but 10 by 2, 2a plus 10 minus 1 into D, which is equal to 125. Further, we can write it as 2 and 5, 10. We can write it as 2a plus 9D, which is equal to 125 divided by 5, and this is nothing but 25. Hence, we are getting the equation as 2a plus 9D, which is equal to 25. Let us suppose I am calling this as my equation number 2. Now, let's just solve the equation number 1 and 2 simultaneously in order to get the value of a and d. So, if we are solving them, so we can write it as a plus 2d is equal to 15. Further, we have 2a plus 9d, which is equal to 25. Let's just subtract them together. So, as you can see, we have to, in order to subtract them, we have to make the coefficient of a similar to that of this one. So, it means we have to multiply this equation by 2. So, let us suppose if I am multiplying this equation by 2, so we will get this term as nothing but 2a plus 4d is equal to 30, and further 2a plus of 9d is equal to 25. So let's just sort it out now. We can see we can cancel the values a and a. We have a minus of 5d, which is equal to 5, and hence the common difference we are getting is 5 by minus 5, which is minus of 1. So at the end we are getting common difference as minus of 1. If the common difference is minus of 1, we just have to find the common difference, which is minus 1. This is my very first answer. And next we have to find the value of a10. So in order to find a10, we have to find a. So if d is minus 1, let's just plug it in any of the equation. Let us suppose I am plugging it in equation number 1. So from this one we can calculate the value as of a plus 2, d is nothing but minus 1, which is equal to 15. So a minus 2 is equal to 15, mean we are getting a as nothing but this would be nothing but 15 plus of 2, which is nothing but 17. So a we are getting as nothing but 17. Now let's just calculate the value of a10. a10 can be written as a plus 9 of d. We can write it as 17 plus of 9, common difference is minus of 1. Hence we are getting 17 minus 1, which is nothing but is equal to 8. So at the end we are getting the answer of a10 as nothing but is equal to 8. So this is my second answer, that the common difference is minus 1 and the 10th term is nothing but is equal to 8.